What if the Big Bang wasn't the start of everything, but rather the most recent episode in a long-running cosmic drama? We thought we knew the story, but new information, better telescopes, and bold ideas are changing it. It's possible that the universe didn't just appear out of thin air. It could be the child of a black hole falling, the echo of an older universe, or the expansion of space itself after a huge contraction. Scientists are finally putting together what might have happened in the mysterious moments before everything we see came into being. They are finding evidence of things like quantum jitters frozen in time and hidden gravitational waves. So what exactly happened before the Big Bang? People have thought about the Big Bang as the most likely way for the world to have started for many years. This model has done a great job of showing how the universe changed over time from a hot, dense state to the web of galaxies we see today. That being said, there is a huge problem at the very beginning that makes the whole plan unstable. You reach a wall when you try to use the equations of general relativity to go back in time. The math stops making sense around 13.8 billion years ago. There are no limits on how dense things can get or how high temps can go, and space-time curves into something we can't explain. It's not just a computer glitch. This shows that the standard Big Bang model does not really explain how the world began. The singularity is the name for this strange place where things begin. But don't picture it as a tiny dot in space that's about to blow up. The singularity is not a real thing. Einstein's general theory of relativity is the best way to explain gravity and the shape of spacetime. It works great for planets, stars, and galaxies. But it doesn't work at the Planck scale around 10 to the power of minus 35 meters, an unimaginably tiny distance. This is where quantum effects dominate. In mathematical terms, the singularity is like a big red flashing sign that screams, "Your theory doesn't work here." In the first unimaginable fraction of a second after the Big Bang, the universe did something extraordinary. In less than 10 to the power of minus 32 seconds, space itself expanded faster than the speed of light. But these weren't galaxies flying apart like shrapnel from an explosion. It was the very fabric of space stretching, dragging everything along with it in a burst of rapid growth that we now call cosmic inflation. Scientists noticed something strange when they looked closely at the universe. The universe seems very uniform no matter where we look. There are very small changes in the temperature of the cosmic microwave background. The basic Big Bang model says that far away parts of the universe should never have come into contact with each other. So this amount of smoothness is strange. Inflation provides an elegant solution. Before inflation, the universe was much smaller, and all of its regions were close enough to talk to each other, exchanging heat and energy until they reached the same temperature. During that rapid expansion, tiny quantum fluctuations, random jitters in energy at microscopic scales were stretched to cosmic sizes. These fluctuations became slight variations in density. Over billions of years, gravity amplified those differences, pulling matter into clumps, forming galaxies, stars, and eventually planets. Without inflation, the universe might have been too smooth for any structure to form at all. Loop quantum cosmology tells a different story, one that doesn't have a singularity at all. At the smallest possible scales, space-time isn't smooth at all. It's granular, made of discrete loops or quanta of geometry. Instead of shrinking into a singularity, the universe reaches a minimum volume and bounces back, starting to expand again. A universe could have existed before ours. In this view, time didn't begin at the Big Bang. Instead, it stretches infinitely in both directions with countless bounces in an endless cosmic sequence. The emergent universe model tells a very different story. The universe didn't start with a violent singularity. Instead, it was calm for an infinite amount of time before it grew quickly, like a cosmic egg. The cosmic egg became unstable, causing the universe to enter an inflationary phase. The universe essentially woke up from an eternal slumber. The ekpyrotic universe says that our universe was formed when two huge higher-dimensional membranes or branes collided in what is called the bulk. When the branes hit each other, they released a huge amount of energy that heated the area and began what we think of as the Big Bang, but without a singularity. Scientists are working to confirm these theories by looking for their fingerprints in the cosmic microwave background and gravitational waves. The question of what happened before the Big Bang remains one of the greatest mysteries in science, pushing the boundaries of our understanding of space, time, and existence itself. As we continue to probe deeper into the cosmos, we may finally uncover the true story of our universe's ultimate origin.